Hello all, we are going to see about AWS OpsWorks. Before we get started, let me introduce about myself. Myself Mahendran, and I am an AWS Certified Solution Architect Associate, and you can follow me on LinkedIn handle, which I have mentioned here. Now let's see the agenda. First, we will see what is AWS OpsWorks, and followed by that AWS OpsWorks offerings, AWS OpsWorks stacks, and its benefits, features of AWS OpsWorks, pricing, and then demo on AWS OpsWorks. Now let's see what is AWS OpsWorks. AWS OpsWorks is a configuration management service that helps you configure and operate application in a cloud enterprise by using Puppet or Chef. AWS OpsWorks provides three offerings. One is AWS OpsWorks for Puppet Enterprise, AWS OpsWorks for Chef Automate, and the third one is AWS OpsWorks Stacks. AWS OpsWorks for Puppet Enterprise, which will lets you create AWS managed Puppet master servers. So a Puppet master server manages nodes in your infrastructure, which will store facts about those nodes and which will act as a central repository for your Puppet models. And the models which I saying it right, so those models can be reusable and shareable units of Puppet code, which contain instruction about your infrastructure should be configured. And the second offering, which provided by AWS OpsWorks is AWS OpsWorks for Chef Automate. AWS OpsWorks for Chef Automate, it lets you create AWS managed Chef servers, which will include Chef Automate premium features, and it also use the Chef DK and other Chef tooling to manage them. A Chef server manages nodes in your environment and stores information about those nodes, and it will act as a central repository for a Chef cookbooks. And these cookbook contain recipes that are run by the Chef infra client agent on each node that you manage by using Chef. And there are other Chef tools like Knife and Test Kitchen, which you can use to manage the nodes and cookbooks on a Chef server in the AWS OpsWorks or Chef Automate. Now we will see more on AWS OpsWorks stacks. AWS OpsWorks Stack is a cloud-based computing. Usually it involves group of AWS resources such as EC2 instances, Amazon RDS instances. So here in this picture, you can able to see a web application typically requires application server, database server, load balancer, and other resources. This particular group of instance is typically we'll be calling as a stack. So AWS OpsWorks Stack will provide a simple and a flexible way to create and manage stacks and application. AWS OpsWorks Stack lets you deploy and monitor application in your stack, and we can easily create stack which will help you to manage cloud resources in a specialized group, which can be termed as a layers. A layer represents a set of EC2 instances that serve a particular purpose, such as serving application or hosting a database server. So layers, it depends on the chef recipes to handle tasks such as installing packages on instances or deploying apps and running scripts. Unlike AWS OpsWorks for Chef Automate, AWS OpsWorks Stack does not require or create Chef servers. AWS OpsWorks Stack performs some of the work of a Chef server for you. And also AWS OpsWorks Stack will monitor the instance health and provide and provision the new instances for you. So this particular technology is done by using auto healing. A simple application server stack this is how it will be getting deployed in AWS OpsWorks Stack. Now let's see AWS OpsWorks benefits. The first one is supports any application. AWS OpsWorks Stack supports a wide range of architectures, from simple web application to highly complex custom application can be used. Since AWS OpsWorks Stack supports chef recipes and PowerShell scripts, you can leverage community-built configurations such as MongoDB and Elasticsearch. And the second one is the configuration as code. AWS OpsWorks Stacks lets you define configurations for your entire environment in a format that you can maintain and version just like your application source code. You can reproduce the software configuration on new instances and apply changes to all running instances, ensuring consistent configuration at any time. And the third one is automation to run at scale. AWS OpsWorks Stack provide dynamic configuration and orchestration that allow you to efficiently manage your application over their lifetime, including support for automatic instance scaling and auto healing. Each new instance that comes online is built to specification automatically and can change its configuration in response to system events. And the next one is the resource organization. AWS OpsWorks Stack lets you model and visualize your application using concepts such as stack, layer, and apps. So the OpsWorks Stack dashboard shows the status of a stack across all AWS region. AWS OpsWorks Stack tags your resource with the stack and layer names to make discovery easier and to support logical group of monitoring, cost allocation, and permissions. And the next one is the supports any server. It will helps you to automate operational tasks like software configuration, package installation, database setup, and code deployment on any Linux or Windows server, including existing EC2 instance or servers running in your own data center. You can use a single configuration management service to deploy and operate applications across your hybrid architecture. Now let's see AWS OpsWorks features. First one is the resource configuration. As I mentioned earlier, we can easily deploy EC2 instances from template configuration, including Amazon EBS volume creation. AWS OpsWorks Stack also maintains and persists the relationship between resources. For example, it ensures that instances keep their elastic IP address and volume even after stopping and starting the instance weeks later. And the second one is the software configuration. We can configure the software on our instances on demand or automatically based on the lifecycle events, from bootstrapping the base OS image into a working server to modifying running services to reflect the changes. When a lifecycle event is triggered, AWS OpsWorks Stack runs built-in recipes that are appropriate for the layer and any custom recipes that you assign to the particular event. So in the demo, I will be showing a kind of a Node.js recipe that is being added for the deploy lifecycle event. So in the demo, you'll get a much understanding about this. App deployment. You can pull your code from a repository and install it on one or all of your instances. And also you can have multiple applications in a stack that are configured to work together as a system. And the next one is the auto healing. AWS OpsWorks Stack can auto heal your stack. If an instance fails in your stack, OpsWorks Stack can replace it with a new one. Automatic instance scaling. You can adapt the number of running instances to match your load with time or load-based auto scaling. The instances in your pool can vary in size, which letting you to scale gradually or quickly, which will allow you to handle the load spikes and save money by only using exactly what is needed. Now let's see the monitoring. AWS OpsWorks Stack sends all of your resource metrics to Amazon CloudWatch, making it easy to view graphs and set alarms to help you troubleshoot and take automated action based on the state of your resources. And it will support Linux and Windows support. We can use AWS OpsWorks Stack to configure and manage both Linux and Windows EC2 instances. On-premises support. You can use AWS OpsWorks Stack to deploy, manage, and scale your application on any Linux server, such as EC2 instances or servers running your own data centers. The next one is the permissions and policy managements. You can grant AWS IAM user access to specific stack, making management of multi-user environment easier. You can also set user specific permissions for action on each stack, allowing you to decide who can deploy new application version or create new resources. You can easily delegate the management of each stack to a specific user or set of users. The next one is the management console and APIs. AWS OpsWorks stack includes a simple web interface, CLI, and SDK that provides the core tools you need to run your application. Built-in features such as Amazon CloudWatch metrics aggregated by layer and the ability to clone stacks within and across the regions will provide the tools needed to streamline application operations. Now let's see the pricing of AWS OpsWorks stack. As I said, AWS OpsWorks stacks can be used on Amazon EC2 instances as well as we can use it on on-premises. There is no additional charges for AWS OpsWorks stack. So you pay for the AWS resources such as EC2 instance, EBS volumes, elastic IP address, which are created using OpsWorks stacks in the same manner as if you are creating them manually. So you pay only for what you use as you use it. There are no minimum fees and no upfront commitments. But for when you are using it for on-premises, the pricing for each on-premise server on which we install the OpsWorks stack agent is $0.02 per hour. But there are no minimum fees and no upfront commitments. Now let's get started with a demo by deploying a sample application, Node.js web application in AWS OpsWorks stack. Let's get started with a demo. I have already logged into my AWS console. Now let's go for AWS OpsWorks. So this is the welcome to AWS OpsWorks stacks page. So here you can see there are three options are available. And as I said, AWS OpsWorks provide three offerings, one for OpsWorks stacks and OpsWorks for Chef Automate and OpsWorks for Puppet Enterprise. We are going to create OpsWorks stacks. So I'm going for go to OpsWorks stacks. And after clicking on that OpsWorks stack, you can able to see we can create a fresh stack, or we can use the regular instances that can be used as our AWS OpsWorks stacks for an easy way to install packages, scripts, or to manage the system users and more. And here you can see we are seeing the benefits. It supports any application and the configuration is code and automation to run at scale and resource organization. So let's get started by creating a fresh stack by clicking on add your first stack. So here there are three options are there. One is Chef 12 stack and Chef 11 stack and the sample stack. Sample stacks, which will have a sample Node.js app, which we can easily launch in a second. In Chef 12 stack, it is supported for both Windows and Linux. And here Chef 11 stack is for Linux. So now I am going to select Chef 12 stack and I am giving the stack name as my Linux demo. And the region I'm choosing as US West Oregon. You can choose the other region as well according to your needs. And I'm selecting the other VPC. And the operating system I'm using is Linux. For the OS, I'm selecting as Ubuntu 18.04 LTS. And here you can see use custom chef cookbooks. I'm going to make use of custom chef cookbook. And my repository is stored in the HTTP archive. So I am choosing the repository URL as HTTP archive so that it can able to download from the S3 location. So here if you see S3 amazon.aws.com OpsWorks, from here it will be getting downloaded. And here you can see for different environment, we can also choose the stack color. So I am just going with the default blue color. And under advanced, you can see whether the root device type need to be a EBS backed or an instant store. So I am going with the EBS backed. And here you can see the IAM role and the default IAM instance profile. These two roles are needed. So by default, it will be there. If it is not there, you can also create on your own. And the API endpoint region, it's US West 2. So the API endpoint region, basically you need to choose which is very closest to your region. So I'm just choosing as US West 2. And I'm just going to click on create ad stack. Our stack has been successfully created. Once the stack has been created, we need to add a layer into it. Why? Because a layer is kind of a blueprint for a set of instance. It specifies the instance resource, installed packages, profiles, and security groups. So I'm just going to add a layer now to this particular stack. So under layer, you can see three options, one for ECS and another for RDS. So if you want, we can add those as well. For now, I'm just going to add a layer by giving a name. So a layer has been added. So under layer, you can see, as I said, right, we can have instance settings, security, EBS volumes, and those things it can be configured. If I click on layer setting, you can able to see the auto healing has been already enabled. So by default, the auto healing is enabled. And the recipe. So here you can see the recipe, right? For each particular event, we can able to deploy it. And under network, we need a kind of a public IP address. So for now, I'm just going to enable it here by clicking on yes, so that it will instance will receive a public IP address every time when I am starting the instance. But if it is going to be a production instance, a recommended approach is you can use the elastic IP address so that it will not going to change for every start and stop. The IP address will be not changing it. It will be constant. And then the EBS volume, we haven't configured that EBS optimized as no. No additional volumes have been added. Root volume alone, it is been configured. And here the security, as we are going to launch a Node.js application, we need to have a security group accordingly. So to add this particular security group, we can click on edit. And by default, the security groups will be there. It will take some time to populate here. So AWS OpsWorks web app will have a required security group, which will have it will enable the user to connect an app to the particular instance. So without the security group, user will receive a message that they can't able to connect to the instance. If we want, we can also, I can also show the security group configured for this web app. Here you can see it, right? HTTP and HTTPS, and it has been opened for 80 and 443 port. So I'm just clicking on save. Once the layer has been configured, now we can create an app. I'm just giving a demo app as a name. And here you can see, you can also choose a kind of data source type as RDS, but for now I'm just going for the default none. And the application source I'm giving as Git, and I am giving the repository URL as This is the one which is kind of, it is available in the on internet. So this is the GitHub page I'm using for to launch the Node.js demo app. So I'm using the same here as well. And if you want to have the revision number, that is also you can provide it. I'm just adding the app to the stack. So this has been done. So once the app has been added, we need to launch an instance, right? To launch an instance, we can click on instances, add an instance. So it will ask for a name, and I'm selecting the size of the instance as T2 micro. And here you can see the scaling type I'm choosing as 24/7. And other than that, there are other options as well, time based and load based. So I am going with the 24/7 scaling type. And I'm just clicking on add instance. As we are launching an instance from here, so at the start, it will be in the status will be in stopped state. To start this particular instance, we need to click on start. So here, the starting of the instance will have almost 5 stages. So from stopped, it will be going to requested stage. From requested, it will go to pending, and from pending, it will go to booting, and from booting, it will go to running setup, and then it will finally, it goes to online. Here you can see it, right? It is now currently in pending state. So after some time, it will move to the booting, and then it will go for running setup, and then it will be online. So requested means AWS OpsWorks will call the AWS Amazon EC2 service to create an Amazon EC2 instance. So that particular state refers to requested, and pending means AWS OpsWorks is waiting for the Amazon EC2 instance to start. And booting means obviously the EC2 instance is getting it is getting booting. So it is getting boot up. And once the boot up is completed, AWS OpsWorks will trigger the setup event and will run the layer setup recipe followed by its deploy recipe. And then it will go to the online state, that is the instance will be ready for use. So now it is currently in third stage, that is booting. So totally there are 5 sections. Let's wait for some more time. It will go for 2 more stages, running setup and online. Running underscore setup, it will go to the next status. Now you can see it is in running underscore setup, and after some time it will move to the online status. So in the meantime, I'm just going to show what are the other settings are available in AWS OpsWorks stacks. So here you can see time-based instance. As I said, a time-based instance is basically uh, to control how many instances should be online at a certain time of the day or days of the week. According to that, our instance will be turned on and turned off. And the load based instances, basically it will be it responds to the CPU, memory, and application load changes across all the instances in a layer. When a metric exceeds its specific threshold, kind of maybe if it is more than 70% of CPU, then it should add more instance. So on that, in that way, load based instance, it will be much helpful on those scenarios. And then here monitoring, you can this particular monitoring, it will be refreshing for every 120 seconds. And here you can see CPU, memory used, load, and the process. And here resources, you can even register your Elastic IP, volumes and RDS so that you can easily attach it to our instance. And under permission, here you can see there are 5 levels are there. So for each permission levels, there is a certain use case. So basically, if you are having a manage permission level, which will combine the user's IAM policy with permission, which will provide full control of the stack. So for each permission levels, there are certain permissions are allowed for the stack. And here you can see the overall AWS OpsWorks stack settings. Now let's see our instance is in online. So it is now ready to use. Now we will deploy the app to the instance. Before we deploy the app to the instance, I'm just going to the layer and I'm clicking on recipe. So here you can see setup, configure, deploy, undeploy, and shutdown. So this is kind of for each event, or you can here you can see it right. It will add the recipe to the specific deploy lifecycle event. So for now, I'm going to add a deploy a recipe to the deploy lifecycle event. So here the node.js underscore demo is the name of the cookbook and default is the name of the target recipe within the cookbook. So once this has been said, what it will do is it will add the recipe to the layer deploy lifecycle event. So when this particular deploy lifecycle event trigger, this recipe will be running on. So I'm just going to my app and I'm going to deploy it. So when I deploy here, you can see the command is deploy. And here you can see, for example, if there are 100 instances or only one instance, this particular app that needs to be deployed, then in that particular scenario, you can select. But for now, as we are having only one instance, I'm going to deploy as select all and I'm going to deploy it. So it will take some time. The status will be changing from running to successful. So once it is successful, here as we have enabled the public IP for the specific instance, when we click on the specific IP, it will redirect to the web page. Let's wait for the deployment to get it completed. And once this deployment is completed, we can also able to see the logs. So to see the logs, you can click on this particular deployment and you can click on log. So it will open another window where you can see the all the logs or how it has been deployed, all those things. Here you can see the starter chef. Here you can see it is checking for the local host. And at the last, you can see the chef run is completed. Now let's see our deployment is successfully completed and our web page is running or not. You can click on this public IP. Here you can see our sample app has been successfully deployed to the AWS OpsWorks stacks. Here you can see it's been page is rendering using Node.js version. So this is how you can easily deploy a Node.js app in AWS OpsWorks stacks. So to delete apps and instances, you need to first you need to delete the app associated to the stack. And once the app is deleted, you need to delete the instance. Before deleting, you need to stop it. Once it is stopped, you can delete the instance and then you can delete the layer. And at the last, you can go ahead and delete the stack as well. Our instance has been stopped. So now I'm deleting the particular instance. So instance has also been deleted. Now I'm just going to delete the layer. So once the layer has also been deleted, we are good to delete the stack as well. So yeah, so this is the kind of a sample Node.js application deployment in AWS OpsWorks. Thank you for watching the video.